Good day, Met 330 students. In this video, we're going to talk about storing more than one data point within the same namespace. And these objects are called arrays. And today we're going to talk about only ones that are one-dimensional. Or if you think about it, things that are either in one column or one row within a table. And so the overarching question that we want to have for ourselves is, how do I store multiple values in one variable name? And why should I even care? And so this idea of arrays is a collection of values of the same type. So in meteorology, we have many examples. So an array could hold all temperatures. They could hold all pressures or all times. And so a 1D, a single array, a single dimensional array, is one column or one row of similar values, such as temperature, pressure, or grades. And so we have a representation here. So we can think of one column. So here, this purple box is our column. And then we have 4 rows within this column, such that we have a one-dimensional array that can hold 4 things. Another way to think about this is that, we have a street that has 4 different addresses, but that everybody lives on the same street. So we're going to reuse that analogy here as we go on to see how we actually do this, how we actually store data in our arrays. And so up to this point, we've just been assigning variables with a single value, whether that be an integer, a real, a character, or a Boolean. But when we use arrays, now we can assign multiple values to the same namespace, but with slightly different addresses. And so initially here, we would have had something that would have been tmpf equals 28.6. Right? That's great. So this variable tmpf is assigned and stores the value 28.6. But if we had a one-dimensional array of size 5, we could store 5 different temperatures in this variable tmpf with just slightly different addresses. And our addresses here are 1, 2, 3, 4, and 5. And so here, if we were writing this exactly in our code, we'd basically be hard coding and saying that in our variable tmpf at address 1, we're going to store the value 28.6. And at address 2, we're going to store 30.5, and so on. And so then if we wanted to access these values anywhere within our program, we would just call the variable name with our parentheses and then the address to get that particular value back out. So it becomes really easy then to start storing a lot of information in one namespace, so we don't have to have 5 different variables. And so why would we need these arrays? And so without that, we would need 5 different variables for the previous example, which wouldn't be terrible. But now let's imagine something a little more meaningful. So imagine a global model with a grid point every degree of latitude, longitude with 40 vertical levels. So that would be 180 degrees of latitude, 360 degrees of longitude, and 40 vertical levels. And so we multiply all those together and we have 2.5 million points. That's a lot of points. We really wouldn't be able to have 2.5 million different variables within our program and make it readable in any way whatsoever. And this would be 2.5 million values for a single atmospheric variable, say temperature. Now imagine we need temperature and pressure and the U component of the wind and the V component of the wind and the W. Whoa, right? It starts really compounding here. And so arrays become very, very useful really quickly. But we don't necessarily want to be able to assign them just hard-coded within our code. We're going to need ways to bring it in and to store things within these levels, or within these addresses. But before that, let's talk about how we declare arrays. So remember, when we're declaring variables, right, we have to declare all of them as either integers, reals, characters, booleans, etc. But now when we're talking about arrays, not only do we need to declare the namespace, TMPF, but we need to declare the size or the dimension of our array. And so there are two different ways to do this. There's the long way in this first example, where we have real TMPF, and then we set up the dimension of TMPF to be 5, so TMPF paren 5 end paren. But we could mash this all together to make it just a little simpler and say real TMPF 5, so we declare the namespace and its dimension all in one fell swoop. So that means we're going to have 5 addresses, and if we ever needed more, then we would just go in and change this 5 to be whatever number we needed it to be. Pretty easy, huh? Now, when we put in 5, we are then basically assuming a minimum size. So the default minimum integer for our addresses in our array namespace within FORTRAN is 1. And so if we just have a single value defining the dimension size of our variable, in this case name, that would be the max value, and the min would be assumed to be 1. But really, we can set up any sort of range that we wanted. If we wanted to go from 0 to 5, that would give us 6 values. And we can even have negative values. So if we wanted to set up a line space where we kind of knew based on an X line from -10 to 10 where things were, we could do that. That's kind of a powerful thing. But for the most part, we can generally run with just putting in the max and using our default min equals 1 value. So what does this look like for a couple of different examples? Here we're setting it up initially the long way for our variable temps, and then setting up our dimensions temps to be from address 10 to address 40. And then, and that would be by ones. Okay, so that'd be 10, 11, 12, 13, 14, so on to 40, inclusive of both 10 and 40. But say we had some data by year, and so we could actually make our integer values, our address values, those years, to make it easier to understand what we're actually going for, or trying to pull out at times. And so we might have a wind parameter, maybe that stores wind speed, from 1940 to 2005. Similarly, we could set up another one to be number from -10 to 10, including 0 in the middle. And then maybe the forecast wind, and so we have our forecast hours of 0 to 23 or 24 hours, 0 UTC to 23 UTC. So we can make these integer values, and again, they must be integer values for our array addresses. Anything we want that might be helpful in us understanding our code and somebody else understanding our code. We can do one better if we have multiple arrays. Say we have some surface data we're going to read in, and we're going to use some different arrays for different types of values. So, for example, temperature, wind speed, dew point, mean sea level pressure. But we all want them to be the same size of array. But that at some point in the future, we may all of a sudden have more. And we wouldn't want to have to go in here and change the size of our array 4 times in this case. And so this is where we can set up something called a parameter statement. And so initially we set up our integer variable of size. And then we use this parameter statement to set the value of size equal to a value. In this case, 24. Then we can use this variable, once we've declared its size, to set up the size of each one of our arrays. So that if we needed all of a sudden 28 variables, then we would just change this size variable once, and that it would spread through all of the other times when we use the variable. Again, doing this sort of thing by the end of your code, by the end of your iteration on your code, is what would make it more sustainable and more reusable in the future. Ultimately, though, we're not going to typically set up a lot of arrays where we're just going to read in data by itself or hard-code it into different addresses within our code. We're going to want to read in a file, maybe a file that has a single column worth of data. And so we can read directly into arrays. And so here we're setting up a variable called grades with 3 addresses. And here we're just doing a simple standard input here. And so we're printing first out to the screen, input 3 grades separated by commas. And then we're going to read in and put into the 3 different addresses, the first grade to address 1, the second grade to address 2, and the third grade to address 3. But we could do something similar. We could instead iterate using our do loop, so now combining some of our previous content on repetition. That since we know we're going to have 3 grades, we can loop 3 times and print input grade number, and then it would print out 1 the first time and wait to read in the grade you're going to input into grades at address I. So what I initially is 1. That's right. And then we hit our end do. I iterates to 2 because our step is by default 1. So then it's going to say input grade number 2, and then wait for your grade that you're going to input and put it in address 2. So this I really is representing 2, hitting end do, and then we iterate to 3, input grade 3, and we put our grade into address 3 for the final time. So we can do it a couple of different ways. We can use our looping to help us out as well, to then automatically put in the correct grade to the correct address. But you can also define your own array, and this might be helpful sometimes when things like number of months or number of days in a month, right, vary. So we have 31 in January, 28 in February, or 29 in a leap year, 31 in March, 30 in April, and so on. And so you can set up your own array. Again, we need to first declare it with its appropriate size. So our variable namespace is called data with 5 addresses. But then we can set up data equals, and then open parentheses / / put in our 5 values separated by commas, n/ and paren. And this is then going to give us an array of 5 addresses that we can then utilize throughout our code. Here we're printing out some information from data, and so we're only going to print out certain values. And so this is called slicing an array. And here we're saying, give me the information from our variable data from positions 4 through position 5. And so again, we start with 1. So 1, 2, 3, 4 through position 5, 31. So it should print out 72 and 31. If we said data 1:3, what should print out? That's right. If it's 1:3, it'd be address 1, address 2, and address 3 inclusively. And so this idea of slicing an array is very important. To get a single value, we just have to reference either with a variable, such as I if we're in a loop, or with a hard-coded variable, the integer value for that address. If we want multiple values, then we could put in a range of integer values separated by a colon. And so in this case here, 3:7 would give us 3, 4, 5, 6, 7, or 5 total values. Look to the next video to have some examples of how these arrays work, reading in and slicing arrays. But that's it, at least for the background on arrays. Thanks for watching.